Welcome to The Explainer. I am absolutely thrilled to have you with us today because while we're tackling one of the most pressing, frankly head-scratching issues facing the automation industry right now, we're going to look at exactly how businesses are radically rethinking their hardware platforms to solve a massive hiring crisis. If you've been anywhere near manufacturing, integration, or machine building lately, you know exactly what I'm talking about. I mean, it's that seemingly impossible task of finding experienced automation talent. Okay. Let's dive into this. Bill Mueller, the founder of Lucid Automation and Security, framed the problem perfectly in Automation World. He wrote, and I quote, "The automation industry keeps trying to hire engineers who don't exist." It is a stark realization, isn't it? But it perfectly frames the problem we're up against. Everyone is out there hunting for unicorns, and the reality of the labor market is just completely different from what demand pretends it to be.
So let's start with Section 1, the Phantom Senior Engineer.
Integrators and machine builders are literally watching vital projects slip right through their fingers. Why? Because that perfectly credentialed hire just isn't showing up. The work is definitely there, but the typical modern automation job posting demands, 3 to 5 years of experience, full stack knowledge of a highly specific vendor's platform, and a completely finished portfolio of projects. But demographic reality paints a totally different picture. The average automation engineer is well past the age of 40, and the pipeline of young talent coming up behind them is remarkably thin. The supply of that perfectly finished engineer is just nowhere near the demand. This leads us to a crucial shift in how we need to view this whole situation. It's not just a talent crisis, it's an experience gap. That's the critical time lost when a newer engineer has to fight a legacy controller's undocumented quirks instead of, actually learning and executing the project. Every single hour spent wrestling with an old, complicated system is an hour of lost productivity. It's an hour where your new hire just isn't progressing at all. Moving right along, Section 2, the cost of complexity. What's really interesting about this is how it reveals the hidden dangers for lean engineering teams, specifically how vulnerable they are to change. The cost of complex systems doesn't just show up neatly on a hardware invoice. When a senior engineer walks out the door of a small integrator or an internal team, they take an immense amount of institutional knowledge right out with them. And it's rarely just about a single product, right? It's that tribal knowledge about combinations, like which servo actually plays nicely with which controller, or which gripper mounts cleanly on which cobot wrist, which vision system needs 3 days of lighting work versus 3 hours. Complex legacy systems literally bleed this vital knowledge every single time a veteran moves on. So how do we fix this? That brings us to Section 3. Traits of winning platforms. If you can't magically conjure 10 more senior engineers into existence, and let's be real, you can't, your absolute best lever is choosing platforms that share 4 vital traits. First, they consolidate roles that used to require entirely separate specialists. Second, they rely on configuration over custom code for the vast majority, like 80%, of everyday tasks. Third, they preserve a clean upgrade path so today's deployment doesn't become tomorrow's absolute legacy nightmare. And fourth, they empower a new engineer to be highly productive on day 1 while still giving a senior engineer the power to do genuinely complex things on day 100. Let's move to Section 4, the modern shop floor, and see how this builds. We're going to take a rapid-fire virtual tour of exactly what these winning hardware platforms look like in the real world across major brand families, starting with Yaskawa's iCube control. Historically, you might have needed 4 completely distinct subsystems. You'd need motion control, PLC logic, safety PLC functions, and robot control. And each one of those required its own programming environment and its own dedicated specialist. Well, Yaskawa collapses all 4 of those into one single controller running on a real-time Linux operating system. For a small, lean team, that level of consolidation isn't just a nice-to-have feature, it is the entire point. And pair right alongside that controller are Yaskawa Sigma X drives. Now, servo tuning is one of those dark arts that practically takes years to master, and it's a super easy place for a junior engineer to just lose a whole afternoon. But these drives, they provide tuningless commissioning right out of the box. With advanced auto-tuning and 3.5 kilohertz bandwidth, newer engineers can instantly achieve rapid settling times that historically used to require hours of tedious hand tuning by a seasoned veteran. Looking over at robotics, the old bottleneck basically meant needing a specialized robotics engineer for every single part changeover, especially in a high-mix, low-volume shop. The modern solution, like Universal Robot's PolyScope X, is a ground-up re-architecture designed entirely around operator-accessible interfaces. What does that mean for you?
It means an operator right there on the floor can perform program changeovers in under 10 minutes without dragging a highly paid robotics engineer into the loop every single time. It's incredible.
And this brilliantly illustrates how the exact same philosophy of accessibility is transforming machine vision. Historically, vision was incredibly hard to staff. It practically required custom C++ coding and a literal PhD in computer vision. Contrast that with Zebra's Photoneo and EV7 stack. It utilizes super simple power over Ethernet plug-and-play setup, and the configuration is built around basic sliders and radio buttons. So now, a newly trained technician can stand up a working 3D inspection cell or a package dimensioning scan tunnel, and it's paying for itself in months. End-of-arm tooling is another classic place where project hours quietly just vanish. But look at this playfully simple installation for SMC's LEHR series electric rippers for cobots. Step 1, attach the universal mount. Step 2, plug in a single M8 cable that carries both power and control. And Step 3, commission it via plug-in software. It drastically reduces the surface area for a less experienced installer to get things wrong. It's basically acting much like a standard household plug. That same philosophy perfectly applies to SMC actuators and chillers. Instead of the trial and error sorcery of tuning pneumatic flow controls and mechanical stops, you use electric precision driven by simple step data tables. And for process cooling, instead of requiring a thermal specialist to deploy an industrial chiller, modern units use basic timers and standard protections. You get all the precise temperature stability your servos and lasers need without, asking your team to magically become refrigeration engineers. Finally on our tour, the Wago Compact Controller 100. This is purpose-designed for machine builders who just don't have a massive dedicated PLC department. What's absolutely fantastic here is that it runs Codesys v3, which crucially is the standard most engineering schools actually teach today. This means your fresh new grads aren't showing up on day one starting from absolute zero, and they aren't getting trapped on a single proprietary system. They are building real, transferable skills immediately. Which brings us to our final section, Section 5, shifting the workload. So the crucial point is this. When you adopt these modern hardware choices, you aren't just buying new gear. You fundamentally change who does what on your team. By utilizing consolidated platforms, plug-and-play vision, and tuning-less drives, tasks like routine cell commissioning and part changeovers move firmly into the junior engineer column. And this incredibly valuable shift frees up your very scarce senior engineers to stay in their lane, focusing on what only they can do, designing the truly hard cells, effectively training new hires, and building robust standard operating procedures. I want to leave you with this final provocative thought. Take a hard look at your own shop floor and ask yourself, are you stubbornly waiting for the perfect engineer to magically appear? Or are you actively building a hardware system where the engineers you already have can step up and be perfect? Rethinking your automation platforms might just be the absolute best hiring decision you ever make. Thanks so much for joining me on this explainer. Keep learning, and I'll see you next time.